All right, let's just jump right into this. We all like to think we see the world exactly as it is, right? But what if the very tools we use to describe reality are actually, in a way, creating the reality we see? It's a huge idea, and that's exactly what we're going to unpack today.
So, let's start at the very beginning. How do we even begin to describe the world around us? I mean, really, when you want to tell someone where something is, or you want to track how it's moving, what's the first thing you do?
The answer is we use coordinate systems. You can think of it like we're throwing a giant, invisible grid of numbers over everything. This grid lets us pinpoint locations, measure distances. It's basically the language we've agreed on to talk about the physical world. But there are infinite possible grids we could use. So how do we choose one? Well, that brings us to our first big point. It really just comes down to convenience.
The process is usually pretty simple. First, we look out at the world, and we see some kind of pattern or an ordering of things. Then, we pick a coordinate system that makes describing that specific pattern as easy as possible.
And why do we do this?
Well, the whole point is to come up with a description that's so good we can use it to predict what's going to happen next. It's how we feel like we understand things.
And this is where things start to get really, really interesting, because we have to make an absolutely crucial distinction between the tool we're using and reality itself.
The best way to think about this is the classic saying, the map is not the territory. Our description, our coordinate system, that's just the map. It's a super useful tool that we invented. It helps us navigate by dividing the world into these neat little parts. But the territory? That's actual reality. It just is. It exists completely on its own, and it definitely doesn't need our lines or our numbers to be what it is.
This quote from the source material just nails it perfectly. It says, reality doesn't need any of our stuff. It doesn't need our perceptions, our man-made laws, our little divisions. The world is just going to keep on doing its thing. We're the ones who seem to need all these frameworks just to get a handle on it all.
So, okay, wait a minute. If we can just pick any coordinate system we want because it's convenient, then how can we ever claim that we found a true law of nature? What makes a scientific law valid if the way we describe it can totally change?
Well, the answer lies in this incredibly powerful idea called invariance. This is the gold standard, the ultimate test for any physical law. It basically says that for a law to be legit, it has to give you the same result no matter what map you're using. The deep down, fundamental properties of whatever you're describing have to stay the same. Let's make this a little more concrete. So imagine we're describing an object. Let's say it's an arrow or a vector, and we're using a standard, straightforward coordinate grid. In this system, we can write down its length and its direction using a very specific set of numbers. Easy enough. Okay, but what happens if we tilt our heads? What if we look at that exact same arrow using a coordinate grid that's been rotated? Well, suddenly the numbers we use to describe it are completely different. But, and this is the whole point, has the arrow itself changed? No way. Its actual real-world length and the direction it's pointing in space haven't changed one bit. That property is invariant. So even though the description looks different, the reality is the same. That's how you know you're onto a true law.
Okay, so it seems like our tools are working pretty well, as long as they respect this idea of invariance. But what if the tools themselves have a fundamental flaw, a blind spot we're not even seeing?
And this is where the source material drops this amazing metaphor. It says that our coordinate systems aren't these perfect, smooth, continuous things. Nope, they're more like beaches made of loose sand.
So what on earth does that mean? Well, think about it. Our grids are made of numbers, and numbers can be discrete, separate, individual points, just like tiny grains of sand. And if that's true, it means our tools are fundamentally gappy. There could be a whole lot of reality happening in between those grains of sand that we are completely, utterly missing. And this isn't just some fun thought experiment. The source makes it clear that our most basic perceptions of space and time are on the line here.
And this is where it all leads. This is the most mind-bending implication of the whole idea. Let's take this loose sand problem and apply it to something we all experience, time.
So here's the question that this whole thing builds to. We talk about moments in time constantly. A moment ago, this very moment, the next moment. But are these separate, distinct moments actually real? Or are they just an illusion, a side effect created by the very tools we're using to measure time?
And this just lays out the two possibilities so brilliantly. The common sense view is on the left. We use numbers to label time because discrete moments are a real feature of the universe. Simple.
But the source completely flips that on its head. It suggests that maybe we only think moments in time exist because we use a system of discrete numbers to describe time. Our tool isn't just measuring reality, it might be creating our perception of it.
Logically, this actually makes a ton of sense. I mean, think about it. If time was just a series of disconnected, separate moments, like still frames from a movie with little gaps in between, how could anything ever move or change? To get from one moment to the next, there has to be some kind of connection, some flow, some continuity.
This all comes back to a classic principle in science, often said in Latin, natura non facit saltus, which just means nature does not jump. Reality is probably a smooth, continuous flow. Our number-based tools might just be giving us the wrong impression, kind of like how a strobe light can make a continuous motion look like a series of frozen, jerky images.
And so, we're left with this one last, absolutely massive question. If the instruments we use to understand the world are fundamentally shaping what we're able to see, if our maps are, in a way, creating the territory inside our own minds, then what are we not seeing? What essential features of reality might exist in those spaces between the grains of sand?